So in chapter 2, we're going to start with rectangular coordinates and graphs. And we're going to kind of just get comfortable by plotting graphs just by plotting points. So we'll learn other techniques in the future, but we're going to start out with our simplest method. So before we can go into our graphs, we've got to talk about the Cartesian plane itself. So it's named after René Descartes, who was a famous mathematician, but it's mostly a way to kind of keep track of your movement based on some origin position. So you have two components. You have an x-axis, which goes across, and you have a y-axis, which goes to the sky. So this breaks that two-dimensional area into 4 quadrants. We start with quadrant 1, where x and y are both positive, and then we move counterclockwise to get quadrant 2, 3, and 4. The point where the two axes meet is the coordinate 0, 0, which is our origin. So this is also called the xy plane or the Cartesian plane, but it leads to this rectangular coordinate system because no matter the point you plot, it creates a rectangle, which tells you the distance you went out in the x direction and the distance you went out in the y direction. So let's just start by plotting each of these points. Anytime you draw, you want to make sure that you give some type of scale. Don't just put tick marks and assume they're going to be 1. Actually go through and put at least a couple numbers to indicate it's going up by 1. So if we plot point A, that's at -1, 2. So for the x, we go to the left 1 and up 2. So here would be A. It's going to sit in quadrant 2. B is the point 1, 3. So we go right 1, up 3, which lands it in quadrant 1. C is -4, 1. So that's going to be down here in quadrant 3. D is 3, -2, which is right here in quadrant 4. For point E, we have 0, 5. So we don't move in the x direction, but we move up 5. So this lands on the y-axis. And F is 3, 0. So you move to the right 3, but don't move in y. So this lands on the x-axis. So if we want the distance between any 2 points now, we can utilize what we learned in the last section with the absolute value, but we can also use our Pythagorean theorem. So if you have 2 points, x1, y1, and x2, y2, we want to go ahead and calculate what is this distance between them. So we're going to call it d. So we're going to go ahead and we're going to draw in a triangle, and we want to find what is the length of each of these sides. Well, really, as you move over here, the y direction doesn't change. And as you move down, the x direction doesn't change. So this point would be x2, y1. So this leg is going to be the difference in our x values, and this one is the difference in our y values. So our Pythagorean theorem tells us that our distance squared is the one side squared plus the other. Taking a square root, we get our distance formula. So let's utilize that to just find the distance between 2 points, -5, 4, and 6, 1. Makes no difference which point you pick to be first or which point you pick to be second. So our distance is going to be a square root. We look at the difference in x's squared plus the difference in y squared. So we just need to simplify. 6 minus -5 is 11. -1 minus 4 is -5. So we get the square root of 121 plus 25, which is root 146. So this would be our exact value. If you do plug it into a calculator, it's about 12.8. So you need to make sure you use this symbol to say it's approximately that. But it is our decimal approximation. So be careful. It asks if your homework or test asked for exact, you want to leave it in this form. If it's going to tell you to give a decimal approximation, it's going to tell you how many decimal points or places you have to go out to. Okay? So let's utilize this idea and this distance formula to see if something is a special type of triangle. So we've got 3 vertices we want to figure out. Is it a right triangle, isosceles, neither, both, maybe equilateral? We don't know. So here are the 3 vertices of our triangle, and I'm not going to be able to know anything just by drawing because we're not going to draw perfectly to scale. What I can do is I can label each of these sides as A, B, and C. So I want to go ahead and first, if it's isosceles, I know 2 of the sides are going to be exactly the same length. So let's go ahead and find length A, B, and C just by using our distance formula. So A, we'll look at the distance between 0, 2 and negative 2, 2. So we take the square root of the difference in x's plus the difference in y's. And if you go through this, A will end up equaling the square root of 20. If we look at B, that's going to be the distance between 0, 2 and negative 2, 2. And so going through this again, you end up with B being the same value, square root of 20. So in this case, I know it's definitely isosceles, but it could still be a right triangle. So the last length I want to find is length C. So I look at the distance between those endpoints, and you end up with C being 4. So it's definitely not an equilateral triangle because C is a different length, but maybe it's going to be a right triangle. So if it is, we can see if it satisfies the Pythagorean theorem. So I'm going to consider maybe this to be my hypotenuse. Then a squared plus b squared should be c squared. Or if I try another way, maybe a is the hypotenuse, then c squared plus b squared should be a squared. So we're going to see if it's actually satisfied, and if it is, it's going to be a right triangle. So first, let's take a and b, square them, and add them together. That gives you 20 plus 20, which is 40. This should equal our remaining side squared. This should equal the remaining side squared, but that's definitely not 4 squared. So it doesn't work with this combination of legs and hypotenuse. So let's try another one. Let's look at a squared plus c squared. So that's root 20 squared plus 4 squared, which ends up being 36. That should equal the remaining leg squared, but it doesn't. If you had switched it around and did b squared plus c squared, a and b are the same, so they're really interchangeable. So since no combinations of these sides actually satisfy the Pythagorean theorem, it's not going to be a right triangle, but it is isosceles. Okay. The next thing we can do is we can look at the midpoint of different line segments. So if you have 2 points, the midpoint is going to be halfway in between those two. So the way you actually find it is you average the x values, average the y values. So you look at the sum of the x coordinates divided by 2, and then the sum of the y coordinates divided by 2. And that will be the point that falls halfway in between. So if we look at the midpoint of negative 5, 4 and 6, negative 1, we go ahead and add the x coordinates together, divide by 2. Add the y coordinates together and divide by 2. So our midpoint will be 1/2, 3/2. Now maybe we don't know our endpoint, but maybe I know the endpoint or the midpoint. So I'm told one of my endpoints is negative 6, 12, and the midpoint is 8, negative 2. So I don't know my remaining endpoint, so I'm just going to call that xy. Well, if I look at our formula and look at the midpoint between these, so if I add the x's together, divide by 2, add the y's together and divide by 2, that better equal 8, negative 2. So then I just set each equation equal to its respective coordinate. So x minus 6 over 2 should be 8, or x minus 6 should equal 16. So our x coordinate of the other endpoint is going to be 22. Likewise, I set the y plus 12 over 2 equal to negative 2. Solve for y, we get y equals negative 16. So our other endpoint is 22, negative 16. Okay. So now that we have this and we're comfortable plotting points, we can go ahead and graph equations by just plotting some of the points that satisfy it. So we're going to look at the equation y equals x squared plus 1. I want to find all of these xy pairs that satisfy the equation. So what I'm going to do is I'm going to pick some values of x, ultimately see what does y equal. So y is x squared plus 1. So I'll square x, add 1, square x, add 1, square x, add 1, and likewise. And I'm going to get all of the different y coordinates which correspond to a point. So this tells me negative 2, 5 is on the graph. This tells me negative 1, 2 is on the graph. 0, 1, 1, 2, and 2, 5. So when we want to graph this, here's our x, here's our y. We need to go up 5. So 1, 2, 3, 4, 5, 6. And we don't need to label every one, we can label every other. And then we need to go out 2 in the x direction. So our first point is at negative 2, 5. Our first point is at negative 2, 5, which is right here. And then it's at negative 1, 2, 0, 1, 1, 2, 2, 5. So all these points are on the graph, and then you could pick more if you want to pick more, but 5 is usually pretty good. And here is the graph of y equals x squared plus 1. Okay. So another important thing that we want to find a lot of time are intercepts. So that's going to be, where does it touch the graph, or touch the axis, or cross through the axis. So the x-intercept is where it touches or crosses the x-axis. Y-intercept, same thing but the y-axis. So if we look at this particular picture, I have 3 points that are going to be our x-intercepts, because that's where it touches or crosses the x. And then I have a single point that's my y-intercept. So if you notice here, for the x-intercepts, when you're on the x-axis, y is equal to 0. That's how we can find x-intercepts. For the y-intercept, x is equal to 0. So you're always going to set the opposite variable equal to 0. So let's just do an example. Let's find the x and y intercepts. And remember, these are going to be points. So you want to make sure you write them as coordinate pairs. So for our x-intercept, we set the opposite variable y equal to 0. Well, that tells us 0 needs to equal negative absolute value of x minus 2. Minus sign doesn't do anything. And honestly, the absolute value ends up not really doing anything either, because the only way you can get something equal 0 is if the inside's 0. So you get x equal 2. So the coordinate for our x-intercept is 2, 0. For the y-intercept, we just plug in x is 0. So you get y equals negative absolute value is 0 minus 2, or y equals the absolute value negative 2. Absolute value negative 2 is 2, but you have a minus sign out front, so our y-intercept is 0, negative 2. So you don't ever want to just write just a point or like the value. You need to write that coordinate pair to represent the intercept.